Question 21. In concentrated alkali, propanone reacts with hydroxide ions to form an equilibrium mixture as shown. I've got water made, so it's some kind of elimination reaction where water is eliminated, or rather the H is removed from here. The H is gone and I've made a double bond, so the OH minus is attacking that H to make water, taking the H off. It looks as if the electrons are going from that H when the OH minus and the lone pair of electrons on the O attacks the H. Then the electrons will go into the double bond, and that double bond on the CO is moving. The electrons in the double bond are moving onto the O. So let's talk through that again. We've got a lone pair of electrons on the O attacking that H to remove it. It will form water. The electrons from that C to H bond then are going into a double bond here to form a double bond, so they're moving from here to here, and then we've got an O minus, so it's formed a single bond from a double, so the electrons from the double are moving on to the O to make an O minus and a single bond. So which does not appear in the reaction? A CH bond going in between the two C's to make the double bond? Yes, it will. So the OH minus lone pair of electrons attacking that H to make water, and the electrons from the CH then move in between the double bonds. That's correct. You'll never see that. You'll never ever see that. That's not such a thing. So the oxygen is electronegative, much more electronegative than the C. So you get a delta minus on the oxygen. So it can go the other way. It can go from the double bond onto the oxygen, which is electronegative and withdrawing electrons along that bond towards itself anyway, but it'll never go the other way. So B is clearly incorrect. Let's just check the others through. Lone pair of electrons attacking the H. Yes, that lone pair of electrons attacking that H. It's the other way up. They've moved it upside down for some unknown reason. But the OH minus with the lone pair of electrons attacking the H. Yes, that's attacking the H there to make the water. And the lone pair of, and the double bond breaking electrons going onto the O and making an O minus and a double bond into a single bond is clearly correct, and that will happen because the O is electronegative and withdrawing the electrons in that direction anyway. So your answer that's incorrect is clearly B. Question 21. A tricky question this. The diagram shows a pH curve produced by adding a strong alkali to a weak acid, which represents the buffer. Remember what a buffer is. So we think this through. Maybe it's not so difficult. When we think this through, a buffer is a solution that prevents the pH from rising. So if we're at A and we're adding alkali, then the pH is rising here. So A isn't acting as a buffer because the pH is rising quite quickly when we're adding alkali. C, when we're adding alkali, that rises quickly. So C isn't acting as a buffer because they add a little bit more alkali and the pH goes up. And D, well, I've got nearly pure all alkali here. Your answer is B. So B, because B, even though I'm adding alkali here, the pH isn't going up until eventually I add enough alkali to make the pH go up, and D is nearly all pure alkali anyway. But here you've got a mixture of a weak acid and I'm adding a strong alkali and the pH isn't going up, so your answer is B.